Wiring a single receptacle is step one, but in the real world, you're almost always wiring more than one. In this video, we're gonna wire multiple receptacles from start to finish on the same circuit using the demonstration wall behind me. We'll also look at 3 different ways to splice the conductors with Wirenuts, with Wagos, and by using the receptacle itself. Hey, my name is Dustin. I'm a licensed master electrician. Welcome to this episode of Smarter Sparky. Before we get started, a quick note. I'm showing this for demonstration purposes only. Electrical work can be dangerous if done incorrectly and may cause fire, injury, or death. Always follow codes, permits, inspections, and safety procedures, and only attempt work if you're qualified to do so. The first thing we need to do is install our boxes. Now, because we're limited for space here, I'm arbitrarily gonna pick a height of 48 inches, just like we did in the last video. And I'm gonna install an outlet about right here, right here, right here, and then we'll also put one up higher here. So we're gonna have 4 receptacles kind of in a row, and we're gonna see how all of the wires actually connect together. Just like in the last video, we're gonna be running a 15 amp circuit, which means we're gonna be using 14 gauge wire. Don't worry, we will be doing a 12 gauge circuit in the future. This is what I have on hand right now, however. So, first things first, we're gonna go ahead and measure out our boxes. Again, I am just arbitrarily choosing a height of 48 inches to the top of the box. So with our 3 boxes down here, our 4th box, I'm gonna arbitrarily put at 6 feet, which is gonna be right up here. And now we can go ahead and nail up our boxes. I've actually got a couple used boxes that I'm going to install here just to keep the costs of this demonstration down. The other 2 boxes will be new, however. So our first box is going to get installed right here, which is a stud pocket away from our panel. These little spacers right here on the box, they are made so that when you slide the box up against the stud, those little spacers actually catch the edge of the stud and actually set the depth of the box away from the stud. Because remember, there's going to be sheetrock here, so we want that box to actually be flush with the front of the sheetrock. We really don't want the box to be recessed behind the sheetrock, so we would definitely not want to install this box flush with the stud. We want it sticking out a little bit, and that's exactly what these little spacers do for us. So we can simply line the box up to the front of the stud with those spacers, and we're gonna line the top of our box up with our mark here, and then we can simply pound these nails in. And there we go, that box is installed. So let's go ahead and install the other 4 boxes. They're done very similarly, so we're gonna kind of go ahead and speed this up here in the video. Again, line up the front of the box, line it up to our mark on the stud, and go ahead and pound it in. And our last box, we're gonna go ahead and install up here at 6 feet. Same procedure, we're just gonna pound those nails in. And there we go, we can kind of see the general layout now. We've got 3 boxes in a row, and we're gonna have a 4th box up high. So let's go ahead and get the wire ran to this. All of these receptacles are gonna be fed from the same circuit, meaning we're only gonna have 1 NM cable leaving this panel, and that 1 cable is actually going to feed all 4 of these receptacles. In order to run the cable from the stud pocket that the panel is in, we're gonna have to drill holes through the studs to get them to the boxes. In order to do that drilling, we're gonna go ahead and use, in this case, a cordless drill, and this is a 5/8 inch auger bit. I've got the drill in low range, and I've got the clutch set to drill mode. In the last video, we actually already drilled a hole in these 2 studs, and I'm just gonna go ahead and reuse those holes. But we do have to drill another hole in this stud. So this will be a great opportunity to see that happen if you missed the last video. Now, the general idea here is we want all of these holes to be in line with each other. So rather than measuring things out, which you absolutely could do, you could throw a tape measure and you could mark exactly where each one of these studs needs to be drilled. But rather than doing that, I'm actually gonna use the previous hole as a guide for where the next hole needs to be. So I can actually go ahead and put my drill in this stud pocket and line the back side of the drill up with that previous hole, and that's actually gonna tell me exactly where to drill. These don't have to be absolutely perfect. Of course, the more perfect you make them, the easier wire pulling is gonna be later, but it's okay if these things are off a 1/4 inch, 1/2 inch. Even honestly, an inch is probably fine for shorter runs. So with my drill lined up to this previous hole back here, I'm gonna go ahead and drill right in the center of this stud. Now, there are codes saying how far from the edge of the stud we need to be. In this case, with a 7/8 bit right in the center of the stud, we've got plenty of space. So we're gonna go ahead and drill through this stud. So now that our boxes are mounted and our holes are drilled, we can go ahead and discuss cable routing strategies. In this case, what we're gonna do is we're gonna leave our electrical panel with what's called a home run. A home run is the first cable that leaves the panel and brings power to a certain location. Then we're gonna need to splice in this first box somehow and continue another cable to the second box. We're gonna have to splice in there and continue with another cable to this third box. And then at this third box, we need to splice again and come out with another cable to go up to this fourth box. Now, this fourth box is going to be a dead end. We will not have another wire extending beyond it. So I've got my roll of 14-2 here. Let's go ahead and unspool some of this and get it ran in the wall. Here's a quick tip on how to unspool these. A lot of people will actually just unwrap all of the plastic from them and unwrap from the outside. I find it better to unwrap from the inside because then you can do this. You can unspool as much as you think you need, and then you can actually unspool from the inside and have your nice straight cable ready to go, and you didn't make a mess out of your spool here. So it's still in its wrapper, and we're gonna be able to just go ahead and unspool what we need outside of the packaging. And there we go. Now we've got a nice set of straight wire, and we're actually still on the spool. So if we do need more, we've still got the ability to unspool more. And furthermore, that spool is not a mess. Wire pulling strategies are going to vary depending on the installation that you're doing. Some are going to be more complicated than others. In this case, this is going to be a pretty straightforward pull. In this case, I'm going to start at the beginning of the pull. So I'm going to start in the stud pocket that the panel is in, and I'm going to push the wire all the way through to my last stud pocket. There are some situations in which you may have to start in the middle of a pull one way and then pull the other way. Those are going to be for more complicated pulls, like in the middle of a house or something like that. So let's go ahead and start feeding this wire through, and I'm just going to pull it all the way through to the very end here and get it in this last stud pocket. Then what I'm gonna do is I'm actually gonna work backwards, putting this stuff into the boxes. That way I can actually just pull more wire through as I need it. So I can loop at each one of these boxes, pull a little bit more wire through, and work my way back towards the panel. I've still got all that wire on the spool, so that way we're not gonna come up short. So the first thing we'll do here is actually take our wire, and we're gonna get up to the last box first. And again, we're gonna then work our way backwards towards the panel, getting wires into boxes and making sure they're all the correct length. So here we are at the upper box, and we just need to get our wire in the box for now. Right now, all we're doing is getting wires to boxes. We're not gonna worry about stripping them out yet. We're not gonna worry about making sure everything is secure quite yet. Right now, we just wanna get wire in boxes. So we're gonna go ahead, and in my case, I like using a needle nose pliers to bust out that back knockout. And then we can go ahead and push the wire up into the box. And there we go, that first step is done. We've got some wire in our box. I'm actually gonna go ahead and loop this around the box just so gravity doesn't pull it down. And here's what this looks like big picture. We've got our wire just put into the box roughly. We've got more than enough wire sticking out. Remember, we need at least 6 inches of wire from where it enters the box available. That is one of the codes in our NEC. So we can actually just pull a little bit more wire through and cut it. So we're gonna have enough to get into this box and have at least 6 inches sticking out of this lower box. So it looks like if we hold this roughly right here, we're gonna go ahead and cut it. And now we can come in the top of this box with this wire that's going up from it. We do not want to use this knockout that's close to the stud. And the reason for that is when they install sheetrock, imagine there wasn't a concrete wall behind this stud wall. Maybe pretend this stud wall is in the center of a room. So we can imagine there's gonna be sheetrock installed on the back of this stud wall as well, right? Well, when the sheetrockers install their screws, if they get a screw in at an angle, there's a good chance that that screw is gonna go into this wire entering the box right here. So we actually need to use this farther knockout. We never want to use that knockout that's closest to the stud. So you're probably asking, well, why does that even exist then, right? You can use this closer knockout if the wall is deep enough. So if we had a 2x6 wall, a 2x6 wall is actually going to put enough distance from the face of that sheetrock on the backside here to this knockout right here that it would be acceptable. I believe it's at least 1.25 inches. So you need at least 1.25 inches from the back of the box to the face of the stud before you're allowed to use this knockout. So for this wire right here, we're gonna knock out this farther knockout and insert our wire that's going up to the upper receptacle. I'll just loop that again just so it's out of my way. So here's the big picture so far. We've got a wire from this box to this box, but now we need to loop to the previous box. So now we need to take our wire coming through the studs here and we need to get another one up into this box. So from here back, we're actually gonna have two cables entering the box, one input and one output. If you wanted, you could absolutely route it something like this, and then you could have one staple up top holding this set of wires together, and you'd have another staple over here on this side. That would be perfectly acceptable as well. It's gonna waste some wire though. So we're gonna go ahead and keep things short, and we're just gonna come in the bottom of the box. So we can just knock out this bottom knockout. Here we go. And now we can feed our upstream cable into the box. Again, we want to make sure there's at least 6 inches of wire from the back. I always like to leave a little extra. It gives you options in the future should you need it. Great, so we've got cable in this box here. Now we need to connect this wire to the previous upstream box. But to do that, we got to remember we're going to have to strap under this box, and we want to make sure these cables stay at nice 90-degree bends. It makes it look a little bit nicer. Yeah, you could, go at an angle like this, but that doesn't look as neat. So in this case, we're gonna go ahead and make sure our wires stay horizontal here and vertical here, and we have a little bit of a bend right here. And now to get this wire up into this box, we just simply pull more wire from our spool, because remember, we're still connected to our spool on that end, so we can actually bring our loop up here, and I'm actually gonna make this long enough for both of the cables that need to go in this box. Because essentially what we're doing is we're gonna basically just cut this wire right here, and that's gonna be the two ends that go into this box. So I'm gonna do kind of two birds, one stone kind of thing here, and I'm making sure we've got enough wire coming up into this box. So if I cut this right here, which I'm gonna do in just a second, I'm gonna be able to stuff both of these cables into this box, and I'm gonna have my in and out right here. So we can simply go ahead and cut this. And because this is one of my used boxes, I've actually already got this knocked out in the back side here. So I'm just gonna go ahead and use that knockout. And we can push both of those cables up together in the same knockout. Again, making sure there is enough wire here to have that at least 6 inches from the back of the box to where we're gonna cut it for the receptacle. Don't think of leaving extra wire here as wasteful. Think of it as cheap insurance that you're not gonna have to re-pull wire later because you found out one of your cables is too short. Then we're gonna do the same thing for this final box. I'm gonna make sure our wire is able to make it to this stud and stay horizontal. I'm gonna pull extra wire from my spool, make sure I can get up into my box, cut this loop. And again, this is a used box that I've already got a knockout in, and I made sure to install these boxes in a way that I'd be able to reuse those knockouts. So now we can put this wire up inside this final box. Again, making sure we have plenty of wire here, and it's okay to have a little extra. And check it out, we're still hooked up to our spool. We really never left the spool. We were always connected, so if we needed more wire, we were able to pull more wire from the spool. And you can actually see it took off 2 little twisties worth of wire there. I didn't have enough spooled out to begin with. Now we need to get up into this stud pocket here, up into the panel. So our wire is gonna enter right here. And again, I cannot stress enough. Always, always, always leave yourself enough wire in the panel to go up to the top of the panel, across to the other side, and down to the bottom of the panel. Again, a lot of people might see that as wasteful. It's cheap insurance that you're gonna not find out later that your cable is too short, and then you've not only got the labor of removing the old wire and reinstalling new wire, but now the wire that you already had installed there is too short and it's scrap now. So definitely put extra wire in. It's not wasteful, it's cheap insurance. What are some situations that you might find that you might need a little bit of extra wire? Well, if you're planning on installing a circuit breaker over here and something comes up that now it turns out you need to install the circuit breaker over here, you're gonna need that extra wire to be able to get to that location. Now on a small panel like this, it's probably not a huge deal, but when you're talking large commercial panels that are 60, 70, 80 plus circuits, you're gonna have a large distance to cover for each of those individual circuits. So use the extra wire, it's worth it. It's not wasteful. Again, it's cheap insurance. So I'm gonna cut the wire right about here, and that's gonna be plenty of wire for us. Now, a word of caution, anytime you are working in an electrical panel, always shut off the main circuit breaker. I know for the first part of this video, you saw this circuit breaker was on, but the way my demonstration setup works here is I'm running it all through this transformer, and this transformer is off right now. So my entire system here is dead. It will not be that way in the real world. In the real world, even if you flip this circuit breaker off, these lugs right here will always be on, and there is no way to turn those off. A lot of modern panels have covers over these lugs, which are fantastic, but a lot of electrical panels in existence still do not have covers on these lugs right here. So just because you turn this main circuit breaker off does not mean everything in this panel is dead. Just to reiterate, in the real world, in a real main electrical panel, there is no way for you to shut off these main lugs right here, which will remain live at all times. A lot of things can go wrong when working in an electrical panel, so make sure you're working within your level of training and always shut off the main circuit breaker. In the last video I did about installing a single receptacle, we knocked this knockout in the panel out and we installed this plastic Romex connector. So if you're curious about how to install one of these in a panel, make sure you go ahead and check out that video as well. So to get the wire in the electrical panel, we're gonna go ahead and grab this and just poke it up through this connector. This little plastic connector has a plastic wedge inside of it that actually allows the wire to push past it, but doesn't allow the wire to come out very easily. If you do need to remove a wire from one of these connectors, you can very gently push a screwdriver up from the bottom and bend that wedge out of the way. So we'll get this wire all the way up in the panel, and I'm gonna leave a little bit of slack here because we still have to go through and do our strapping, which is what we're gonna do next. Once we get everything strapped, then we can pull these cables up a little bit tighter. For right now, I'm just gonna loop this cable up in the panel. That way it's out of my way. Next step is gonna be installing our wire staples. In the video I did about installing a single receptacle, I mentioned that Romex, or NM, needs to be strapped within 12 inches of entering the box, and that is true. However, I made a slight omission in that last video. When Romex, or NM, enters a non-metallic box that does not have a strap built within the box, we actually have to strap within 8 inches of the box. So we're gonna actually have to make sure we strap within 8 inches of these non-metallic boxes, just because these non-metallic boxes don't have any sort of connector built within the box. Arbitrarily, I'm gonna start at the last box and work my way towards the panels, strapping the wire as I go. So outside of each one of these boxes, we have to put one of these staples within 8 inches. So in this case, we're gonna need a staple between here and here. Somewhere in there, we have to have a staple. As a beginner, you might have to measure these out the first couple times until you get the feel for where within 8 inches is. In this case, I'm just arbitrarily gonna that's about what, 5, maybe 6 inches right here. I'm gonna go ahead and put my staple right here. We also want to make sure we are stapling the cable in the center of the stud. Remember, we've got that 1.25 inch requirement that says we have to have no cable within 1.25 inches of the face of either side of the stud. And coming into this third to the last box, we need to do the same thing within 8 inches, and we want to make sure the cable is in the center of the stud. And on the bottom side of this box, we're gonna do the same thing. I'd probably usually put my staple right about where this hole is. I have used this demonstration wall before, so I've got another hole right here. So I'm just gonna avoid that by going slightly underneath it. We're still gonna be within that 8 inches though. Again, right in the center of the stud. And now with this one done, we need to go ahead and staple these two as well. This one right here, we can actually put both cables under one strap. It still has to be within 8 inches, however. Also, when you're strapping 2 cables at a time, make sure one of the cables doesn't slip and you drive a nail through the cable. That's always a bad day. And our last box here, we're gonna do the exact same way. You gotta try to make sure you stack these so they're not all twisted around each other. So you're not gonna wanna strap it like this. That would just look sloppy where you've got the twist in there. So we wanna make sure these are sitting on top of each other as straight as possible. And finally, we have the strap coming out of the panel. Now, these non-metallic boxes had no clamping mechanism in them, so we had to strap within 8 inches. This connector that we installed in the panel, however, is considered a clamping mechanism. So we need to strap within 12 inches of the panel. These were an exception because they don't have a clamp mechanism in them. If these had a clamp mechanism, we could have strapped within 12 inches. So we just need to strap within 12 inches of the panel. Again, we also want to make sure the cable is within the center of the stud. So at this point, it's time to start making up our boxes. In each one of these boxes, I'm going to show a different methodology of how to do these splices. There are actually 2 major ways of doing these splices. My preferred method is what's called the pigtail method. So we're gonna have wires coming into the box. So we've got our in and out right here, and we're actually gonna use wire nuts, or I'm also gonna show Wagos in one of the boxes as well. And we're gonna have a set of wires that actually don't leave the box. These are called pigtails. These little short pieces of wire are called pigtails. So we're actually going to land only basically one wire on each receptacle, but then they're going to go to a set of wire nuts and everything's going to be wire nutted together right here. The other way of doing this is by using the actual terminal screws on the receptacle itself. So we don't have a second set of splices, we don't have any extra wire, we still have to splice the ground wire. There are some techniques on how to get by without needing a pigtail here, but that does get a little wasteful, so I'm not even going to bother mentioning that. But this is another method. A lot of people, myself included, do not like this method. Most, not all, but most electricians do not like this method simply because of the fact that we are relying on the receptacle itself as a splice. So if this receptacle were to fail, it actually might cause all the downstream receptacles to fail also. So while it is not against code to do this, this is perfectly acceptable per code, and a lot of people actually argue that that is the reason for having multiple screws on a receptacle. And while that might be true, my understanding is the main purpose for having the multiple sets of screws on a receptacle is so we can actually break the tab between the 2 sets, and we can actually control these individual receptacles individually. That'll be a topic for a future video. My preferred method is the pigtail method. In my personal opinion, it seems more robust. It's not relying on the device itself as a splice point, and it can make troubleshooting a lot easier. I absolutely see the appeal to using the terminal method. It's 2 less wire nuts, it's 2 less pigtails, and it actually saves a little bit of time. You're stripping out the wire anyway, but you're just looping it and installing it on the receptacle. I definitely get the appeal to this. So we can go ahead and start preparing our boxes. So I want to get these boxes to a realistic stopping point of where we would call the inspector in to get a rough-in inspection. Remember, the rough-in inspection is where we call the inspector and have them come and look at everything inside the wall before we put sheetrock on. Because I'm going to be showing 3 different methods here, we're going to have to get these boxes to slightly different stopping points, and I'll mention those as we go through them. This first box we're going to make up like this with wire nuts. The second box, we're gonna also do the pigtail method, but we're gonna use Wagos instead. And in this third box, I'm gonna demonstrate using the terminal method on the receptacle itself. And the fourth box is just gonna land directly on the receptacle, as there is no splice in this last box. This is just a dead end. So these first 2 boxes, we're actually gonna have to strip everything out, and we're gonna do all of our terminations right away. This third box, we're gonna get everything stripped out, and we're just gonna end up shoving the wires back in the box. And we're gonna do the same for that upper box as well. Then we're gonna be at a stopping point of where we can call in for a rough-in inspection, and then we'll go ahead and look at how to terminate the receptacles in these boxes. So in our wire nut box, I'm gonna go ahead and strip these NMs out. I like to use a utility knife. When you use a utility knife to strip out NM, all you're doing is scoring it. So I'll just do an example right here. I just scored through just enough that the outer insulation is starting to split. And then we can give it a pull and actually tear it the rest of the way. But check it out. I did not actually cut through enough to even cut through the paper completely. So the point is we're just scoring this outer sheath. We do not want to be cutting the insulation on these inner wires. And for a beginner, that can be very difficult. I used to struggle with that a lot. You are only using light pressure to score through the insulation here. Now this was just a demonstration. We want to actually strip it out farther back in the box. You do still want some of the outer sheath coming into the back of the box, but we don't want a long portion of it in the box. So I am gonna reach into the back of the box with the knife and just gently score it. Unfortunately, we're gonna have to do it kind of at an angle because of the geometry of the box. And we can pull that straight out. And we can pull this little piece of paper around the ground off as well. If this piece of paper here stays on the wire, you can also just rip that off as well. And we'll finish stripping this one out also. See, like right here, the paper stayed on. All we have to do is just rip that off. And we can rip the paper off from around the ground as well. So at this first box, we are going to be splicing using wire nuts. Now the code says we have to have at least 6 inches of free conductor from where the cable enters the box. So we're going to want to cut these wires approximately right here, 6 inches from where it enters the box. I'm just going to cut all of them at the same time. I'm going to use some of this scrap as our pigtails. So really, we're not wasting anything by having extra wire there. Sure, these little bit of shorter ones right here, this is scrap right here, but this we're actually going to use as our pigtails because we need some wires to go from our wire nut splices to the receptacle itself. I'm going to start by stripping out all of the wires, including these pigtails. We want to strip these out approximately to 5/8 of an inch. Now with everything stripped out, I'm going to grab these in pairs. I'm going to start with the ground wires, line them up, bring in our pigtail piece, line it up as well. And because these are all the same size and type wire, we're going to make them flush. If you want to learn more about using wire nuts, I made an entire video discussing wire nuts. Link in the description. So with everything lined up, we can simply start twisting our wire nut onto the ground splice. And there we go. The ground is pigtailed out. Now we can move on to the next set of wires. I'm going to go with the neutrals next. Line the tips of the wires up and grab our neutral pigtail. Line all of the neutrals up and we can twist the wire nut on. Anytime we make a splice with a wire nut, we want to do a tug check. Pull on every single wire. Nothing should move. If even one of your wires moves coming out of the wire nut, when you do your tug check, you have to redo the entire splice. That means it is not solidly connected. And lastly, we can do our hots here. Grab our pigtail for the hot, line everything up, and twist on our wire nut. And there we go, everything is spliced. So to get ready for the rough-in inspection, we need to shove all of these wires in the box and get it ready for sheetrocking. So we need to shove this mess of wire nuts into the back of the box. I like to pick up on the center of the wires here and shove the whole mess in the back of the box like so. I mentioned in the wire nut video that wire nuts are hats, not buckets. So we want to make sure our wire nuts are facing upwards. We do not want our wire nuts to be upside down in the box because moisture and debris can actually find its way into the wire nut and cause premature failure of that splice. So wire nuts are hats, not buckets. Make sure they are facing upwards. So with this splice shoved in the back of the box, now we can pull our pigtails to the front of the box and leave them bundled together like so. So with our wires safely in the back of the box, when the sheetrocker comes to put the sheetrock on the wall, all they do is they just put up a big piece of sheetrock and then they come through with a rotozip later and they actually cut out the box from the sheetrock. So it's very important to make sure your wires are as far in the back of the box as possible because that rotozip blade has a tendency to be a little too deep and they will cut your wires as they cut out the sheetrock for your boxes. All right, with the wire nut box done, let's let's move on to the Wago box. I don't have much experience with Wagos. All the shops I've worked for, we've always used Wirenuts. The shops have always been too cheap to buy these Wagos. They seem pretty neat, so let's give them a try here. The principle for this box is going to be the same. We're gonna have to get everything stripped out, and we're gonna have to make a set of pigtails so we can jumper to the receptacle once we get to that phase. First step is to strip out the Romex cable, or the NM. Great, now we've got our cable sheath stripped out and all of our conductors exposed. Now we need to cut these conductors down to 6 inches from where they enter the box. So again, just for the sake of seeing this on camera, that would be roughly right here. So I'm gonna go ahead and cut all of the cables right here. And I'm gonna use the longest set of these scraps as my pigtails. These particular Wagos have a strip length of just shy of 1/2 inch. So we'll get everything stripped out just shy of 1/2 inch. With the Wirenuts, we stripped them out to about 5/8 inch. So these Wagos we're stripping out just a little bit less. So the way these Wagos work is there is a lever built into them, and you lift that lever up, and then you can insert your wire into the corresponding slot and close the lever, and it actually grabs the wire and makes the connection within the connector. So just like with the Wirenuts, I'm gonna grab these wires in pairs and open all the levers on my Wago. These are 3-position Wagos. You can get these things in quite a few different configurations. So I'm gonna put a ground under each of these 2 levers and flip them down to lock on. And this third ground we'll put in the 3rd and final position. And there we go, that's our splice made. No twisting, no messing around. And we'll do the same for the neutrals. Open up the levers, 2 of the neutrals under 2 of the positions. We're gonna wanna make sure that there is no insulation up underneath that metal strap in the back. And then we install our pigtail in the 3rd and final position. And there we go, our neutral is done. Let's do the same for the hot. So 2 of the hots under 2 of the positions. Close the levers, and our pigtail goes into the 3rd position, and there we go. Same thing, we're gonna wanna double check that there is no insulation up underneath this metal strip within the Wago connector. Here we can see there is copper visible on both sides of that metal strip, so that's a good connection. Now same thing like we just did with the Wirenuts, we have to fold all these wires into the back of the box to get ready for the rough-in phase. Just like with the Wirenuts, these Wagos should be hats, not buckets. We want stuff that's gonna fall down into them to shed off and not get caught up inside the connection. So we're gonna wanna make sure these things are facing up. And then with our pigtails, we're gonna want to loop them towards the front and then shove them all in the back so they don't get caught with the roto-zip when they cut the sheetrock open. On this last box, we're only gonna be pigtailing the ground because on this box, we're gonna be installing the receptacle this way. So there's not going to be any pigtails on the hot and neutral. We're actually just gonna use the terminal screws on the device itself as the splice. Again, there is nothing in the code that says you can't do it. This is not my preferred method though. I very much prefer the pigtail method. So just like with the previous boxes, we need to strip out our cable. And we can remove the paper from the grounds. Now, like I mentioned earlier, there's quite a few different things we could do with these ground wires. In this particular case, I'm simply going to pigtail with a wire nut. You could use a Wago as well. They do make special green wire nuts with a hole in the tip. I talk about those in my wire nut video, so definitely go check that out if you're curious on the different types of wire nuts as well. So in this case, we still want to cut back about 6 inches from where it enters the back of the box. And I'm gonna use one of these pieces of scrap as my pigtail. We'll put the wire nut on our grounds here. The grounds are done. And remember, there is nothing we need to do. There are no splices we're gonna make on the hot and the neutrals here, but we are gonna cut them to length and coil them up in the back of the box because we do have to get this ready for rough-in inspection, and we want the wires out of the way for when the sheetrock is installed. So we'll cut that approximately 6 inches from where it enters the box. Remember, wire nuts are hats, not buckets, so we want that wire nut to be facing up, and we'll loop the hot and the neutral into the back of the box, and we'll coil that ground up there as well. So those are as far as I can smush them into the back of the box. That is ready for inspection and sheetrock. And finally, at this upper box, there's really nothing that needs to be made up. We are gonna strip out this cable sheath, and then we're gonna tuck the wires into the back of the box to get it ready for that rough-in and sheetrock. Now, I am short, so let's see if I can see up here to do this without a stepladder. And I am gonna trim these wires up just a little bit. If you leave your wires too long in these boxes, it makes them more prone to getting caught by that roto-zip blade. And with that, we are ready for rough-in inspection. Again, rough-in inspection is where we have to call the inspector to come in and look at everything that's gonna get covered up within the wall. So after the rough-in inspection passes, the sheetrockers can come in and cover up the wall. So let's pretend it's a couple weeks later, the rough-in inspection has passed, the sheetrockers have been there, have everything nicely painted up. We are ready to go through and device this out now. And let's just start with this first box right here. So once we come back to a box after the wall has been finished, hopefully all of our wires are still intact. And we can go ahead and pull out just the 3 wires that we left there. Remember, this first box we did the pigtail method. So all we need to do is pull out the pigtails. We're gonna strip these back long enough that we're able to make a good loop. This is roughly 1 inch, and we'll strip out the neutral as well. I like using these needle nose wire strippers. Makes grabbing the tip really easy to put a loop on. And we'll put our loops on all 3 of these wires, hot, neutral, and ground. And now we're ready to start installing these. So I'll grab my ground wire first and put that loop around the ground wire. We want to make sure that that loop gets installed on the terminal in the direction that the screw is going to turn when we tighten it down. So as we tighten this screw down, it's grabbing the wire, and it actually pulled a tiny bit more wire in as that screw gripped and spun around. If we were to have that loop in there the opposite way, it would actually push wire out. So we wanna make sure these loops are the direction that the screw is tightening. Now we'll go ahead and do the same with the neutral. The neutral wire gets landed on the silver colored terminals. The brass or gold colored terminals are the hot. Another way of looking at it is on a receptacle, the larger of the eyes, if you will, on the face that's a receptacle, the larger eye is the neutral, and the one that's winking at you is the hot. So on the silver screw, we're gonna put our neutral. You could choose either one, it doesn't matter. And snug it down. Again, making sure that the wire is looping the same direction that the screw is tightening. It is also a good habit to tighten down the unused screws on the receptacle. It lessens the chance of one of the wires touching this bare ground wire in the box. Lastly, we can install the hot wire on the gold colored terminals. Again, same thing, we wanna make sure that wire is looping the same direction that the screw is tightening. And we'll go ahead and tighten up that extra screw as well, just so it's not hanging out there. And there we go, this receptacle is terminated. So we're gonna push our wires back into the box, and we can start tightening these screws down and install the receptacle within the box. I'm gonna cheat and use a drill. Definitely don't wanna go hog wild with these screws. Remember, these are plastic boxes, and you can easily strip out the box. There we go, first box done. Now let's move on to the Wago box. It's actually going to be the exact same steps for this particular box. It actually doesn't matter that we have Wagos back in there now. As far as we're concerned, we just have a couple pigtails sticking out that need to be landed on the receptacle. So we'll go ahead and strip out these pigtails as well. Approximately 1 inch. Put a loop on the end of all 3 wires, the hot, the neutral, and the ground. And there we go. We've got 3 hooks ready to be installed on our receptacle. It is good practice to land the ground first. That way, if something becomes energized while you are working on it, remember, you should never work on live circuits. Always shut your circuits off. But in the event something goes wrong, something happens, having a solid ground there is a lot better of an opportunity to trip the overcurrent device, shutting the circuit off in the event of a short circuit. And our neutral, and finally the hot. Again, making sure that that wire is looping around the terminal the same direction the screw tightens. Additionally, you want to make sure no copper is extending beyond the back of the receptacle here. We don't want this copper stripped back any farther. You do not want to see hot or neutral beyond the back side of the receptacle. And before we put this box together, let's go ahead and tighten down those extra screws. This is just kind of a bit of insurance that we're not going to short something out when we put this receptacle in the box, especially because we've got that bare copper conductor as our ground wire. So with both of those screws tightened, we can go ahead and put our receptacle in the box. Notice how I got everything snug but haven't tightened everything up yet. That's because once we get real close to everything getting tight, we can actually move this receptacle around on this slot up here. I'm gonna go ahead and make sure everything is centered and tighten that down so our receptacle is level. Sometimes these studs can be a little crooked and we can compensate for that on the slots on the mounting yoke of the receptacle. Now at our third box, remember we didn't do any pigtails here except for that ground. So in this case, we've still got 4 wires here, and we're actually gonna land these on the receptacle. So because all 4 wires here are gonna land on the receptacle, we actually need to strip all 4 of these out so we can put loops on them. So we'll strip them all out approximately 1 inch, maybe just shy, 7/8. And we'll put loops on each of these. Also, don't forget, we've got this ground that we did have to pigtail back here. So let's bring that out and put a loop on it as well. And now we're ready to install the receptacle. I'm gonna start with the ground. Again, we wanna make sure that wire is installed the same direction the screw is going to tighten. Then we're gonna install the neutrals. Now in this case, we're actually gonna be using both sets of terminals. Make sure the neutrals are going the same direction the screw is going to be tightening, and we can tighten both of them down. Again, taking care that there is no copper sticking out beyond the back side of the receptacle. Flip it over, and on the winking side of the face, our gold colored screws, we need to land our hots. So we'll go ahead and tighten these down. Again, same direction that the screw is tightening. That way when the screw snugs down, it pulls more cable in. There we go. No copper sticking out beyond the back side of the receptacle. And now we can mount the receptacle to the box. And there we go, that one is done. And lastly, we've got this upper receptacle. Here we do not have any splices that need to occur. We're just simply going to pull out these 3 wires and land them directly on the receptacle. So our hot and neutral, we need to strip out to put a loop on. And the ground, we can just put a loop on directly. And there we go, 3 loops ready to go. Green is the ground screw. We gotta make sure it is looped around the screw the same direction the screw is tightening. I know I've said that 100 times. I'm gonna say it 100 more, I promise. We gotta make sure that is done correctly. Otherwise, the wire will back out and it'll create a bad connection. Silver terminal is our neutral. And lastly, the gold terminal is our hot. And let's tighten up those extra screws that aren't used. That way we reduce the chance of a short circuit within the box. Same for that neutral. If the ground were to touch the neutral, that would create what's called a ground fault, which may be the topic of a future video. Now we can fold our wires up into the box and mount the receptacle. And there we go. Now with the receptacles installed and completely wired, we can go ahead and put covers on these. I have one used cover here I'm going to install, and then we're going to install some new ones. I do not recommend installing these with a drill. Definitely want to use a screwdriver. Some of these plastic covers can break very easily. So we just line it up with our receptacle and spin the center screw on. And that's all there is to installing a receptacle cover. One thing you're going to want to keep in mind is that when you're installing these receptacle covers, you're going to want clean hands, especially on these really nice white covers. Any tiny little bit of grease or dirt on your hands is actually going to smudge on these quite a bit. So you're going to want to make sure you've got clean hands and you're not making these dirty. A customer is not going to want dirty receptacles, dirty faceplates, or even more importantly, the wall around the receptacle. If you're putting your hand here, remember we're pretending there's sheetrock here. If you're putting your dirty hands on a nice cleanly painted wall, you will leave smudges and they are noticeable. And we'll knock out this third one. Just like we've discussed in past videos, we want to make sure we have a consistent position that we leave our screws in. I know it sounds crazy, but again, it's that last little cherry on top that makes your installation stand out past those that might just leave their screws at a 30-degree angle or some arbitrary angle. Always leave your screws at a particular position. That way there is consistency across your entire installation. I prefer to have my screws straight up and down. There are some electricians out there though that like theirs horizontal. Totally up to you, just be consistent. And our last receptacle here. There we go. Receptacles are done. As I mentioned before, anytime you work in an electrical panel, make sure your main circuit breaker is off. But when your main circuit breaker is off, there are still live terminals within your panel. So if you're working in an electrical panel, make sure you're qualified to do so. As I mentioned before, we're going to be installing a 15 amp circuit breaker. I am arbitrarily going to install this particular circuit breaker in this top position here. The way this particular panel works is there is a clip in the back here that clips on this plastic piece right here. And then on the main bus bar, there is actually a terminal that clips on it as well. So now we've got a target for where our wire is going to land. Remember, we left ourselves plenty of wire here, and a lot of people look at this as waste. It's not waste, it's cheap insurance. Yeah, in this case, we put our circuit breaker right here, everything worked out very well. But if something were to come up during the installation, let's say we've already ran this wire, and we were gonna plan on putting it here, so we only cut it this long. Well, what if something comes up and now the circuit breaker needs to be over here? We would actually have to have quite a bit more wire to reach that location. Always leave yourselves options. Don't look at this as waste, look at this as options. So we're gonna actually bring our wire to this circuit breaker, but we've got 3 wires in here. First thing we're gonna do before we get ahead of ourselves is strip out our cable. Again, we want about 1/4 to 1/2 of an inch of insulation within the panel, and then we're gonna strip out the rest. Being careful not to cut the insulation on the wires that are within the cable. So the black wire, the hot wire, that's what's gonna go to our circuit breaker. But where do we bring these other 2 wires, the neutral and the ground? Because this is a main electrical panel, we can actually share the neutral bus bar. The ground and the neutral can both land on this bus bar. If this were a sub panel, we would have to separate the ground and the neutral. That will be a topic of a future video all by itself. So because this is a main electrical panel, we are gonna share the neutral and the ground at this particular bus bar. Does that mean the ground and the neutral are the same thing? Absolutely not. The ground and the neutral are 2 very different things. They just happen to land at the same place. After the electrical panel, they need to be considered 2 totally separate entities, and they cannot be swapped for each other. And again, that will be topic of that entire video, just talking about why grounds and neutrals have to be separate, but in the main panel they can be together. So I've got these bent roughly into shape, and it looks like it would be very convenient to use this screw and this screw. So I'm gonna go ahead and use my left index finger to mark roughly where I'm gonna cut these. We wanna be able to have just enough wire to go to the back side of that bar. So I'm gonna cut it right about where my finger is at. And we'll strip out the neutral. And now we can slide both of these wires under their respective terminals and snug them down. And now with the hot, we're gonna kind of roughly put it in the shape that we want it. We want everything tucked in the corner of the panel. We want everything to look neat. We do not want to line of sight our wires. It's gonna make it look like a mess in here. So we wanna kind of go at nice 90-degree angles, leave everything nice and neatly organized. And it looks like roughly right about here is where I'm gonna have to land on this terminal on the circuit breaker right back here. So I'm gonna go ahead and mark it with my left index finger and cut it right there. We're gonna strip this out roughly 1/2 inch. And then we can slide the hot wire underneath the terminal on the circuit breaker and snug that down. You don't want to over tighten these because notice how that square washer has started to turn. If you torque on that too much, it can break that square washer through the side of the circuit breakers and short something out. Before we fire this back up, let's install our panel cover. Because this is a used electrical panel, I've actually got some knockouts here for additional breakers. I went ahead and bought some proper circuit breaker blanks here, and we'll just install these circuit breaker blanks to cover those up. You definitely don't want to fire up an electrical panel with those knockouts out. Somebody could stick their finger in there, or something crazy could happen and arc out or electrocute somebody. Make sure this circuit breaker is off so we can power everything up first and then fire up that last circuit that we just added. So I'll turn on my transformer here, and we can flip the main circuit breaker. And let's go ahead and turn on the receptacles we just installed. And last but not least, we have to check our installation with a receptacle tester to ensure that we wired it properly. In this case, when we plug this in, 2 orange lights should come on saying that it was a correct installation. Any other combination is going to mean we have a wiring issue. So let's go ahead and check all 4 of our duplex receptacles. It's just as simple as plugging it in. See, we've got 2 orange lights. That receptacle is good. This one, 2 orange lights, receptacle's good. 2 orange lights, good. And our last receptacle, 2 orange lights, that receptacle is good as well. Wiring multiple receptacles ties together a lot of the basic skills you use on the job or at home. As an apprentice, you might not do every step from start to finish in a single task, but you will be doing each of them repeatedly across a job. If you're a DIYer, understanding how these pieces fit together will help the bigger picture come into focus. If you made it this far in the video, consider liking and subscribing. I enjoy reading your comments and try to respond to everyone, so don't forget to leave a comment as well. Thanks for watching. We'll see you on the next one. Bye.